Our first success criteria in chemistry is learning how to distinguish between the English and metric systems of measurement. And in this video, we are going to define the metric base units and learn how to list the metric prefixes by increasing order. So far in your life, you've used the English system. You've used inches, feet, and miles for distance, pounds to describe how heavy something is, and things like ounces to describe how much space an object takes up, or in talk about their volume. We've also used Fahrenheit for temperature. But there are so many different things that we can measure, and the metric system allows us to have a way to have a common language with the rest of the world. So the metric system actually has 8 base units, which describes the 8 types of measurement that we can take. The first is the meter, typically used for distance. We abbreviate with a single lowercase m. The next is the kilogram, which we abbreviate K for kilo, which is actually a prefix, and we'll talk about that later, and G for gram. This is used for mass and not weight because they're 2 different things. The next base unit is the liter, which we abbreviate as a capital L, and that's to use for volume. And you might be familiar with that for 2-liter soda bottles. Temperature is actually represented by Kelvin, which is the absolute temperature scale. So when we talk about absolute zero, we actually mean that when there's actually no molecular movement. So everything would be stopped, which means that we would be dead. The mole is something you probably haven't heard of. It's abbreviated MOL, which I know seems like a really silly abbreviation because it's only short 1 letter, but it's extremely important in chemistry. The second, abbreviated with a lowercase s, is the base unit for time. And then other 2 base units which we're not going to use are the candela, which is CD, which is used for light, and ampere, which is used for voltage and electricity, abbreviated AMP. Now I'm sure you've heard of all these base units before, but you haven't known the relationships between the English system and the metric system. So some ones that are important to have in your back pocket is that 1,000 meters is equal to 1 kilometer. Now you might know people who run 5Ks, that's 5 kilometers or 5,000 meters. To relate inches to meters, we know that 39 inches is equal to 1 meter. So ask yourself, which is longer, a meter or a yard? For mass, we can say that 1,000 grams is equal to 1 kilogram. And that for every 1 kilogram of matter that there is, that's equivalent or equal to 2.2 pounds. So sometimes when you go to the doctor, your weight is taken in kilograms and not pounds. And the kilogram is always going to be the lower of the 2 numbers. For volume, we're going to work in milliliters a lot in chemistry, and 1,000 milliliters is equal to 1 liter. We also know that 3.78 liters is equal to 1 gallon. Temperature, which even though the base unit is in Kelvin, we're going to use Celsius in chemistry. And Kelvin is equal to 273 plus however many degrees Celsius that there are. Like I said before, the mole is super important for chemistry, and 1 mole is equal to 6.02 times 10 to the 23rd particles. And last but not least, time. 1 minute is equal to 60 seconds, but 1 hour is equal to 3,600 seconds. I'm sure you're wondering how all of these conversion factors came about, especially those with numbers that are not part of the powers of 10, so like 10, 100, 1,000. All of those, especially the mole, came from a lot of experimentation within the last 500 years. In chemistry though, even though there are 8 metric base units, we're only going to focus on 4 of them. Kilogram for mass. Now you are mostly know this for pounds. And kilograms represent the mass of different objects. So we're also really going to use just the grams in chemistry because we aren't going to be using a lot of matter. Liters represents volume. We're really going to be using milliliters more often because we're going to use smaller amounts. Now you might know them volume for ounces by heart, like 12-ounce soda, 16-ounce coffee, but all of those have a metric equivalent. Temperature, like I said before, we're going to be focusing on Celsius. All of our thermometers are Celsius based. And the mole doesn't have an English system equivalent, but we have to remember it's used for counting the number of atoms or molecules. And that part you're going to have to be a little verbal on. Now with those base units, we're also going to need to have prefixes because the metric system uses prefixes in order to have different values or different units. K stands for kilo, which is representative of 1,000. Now this is like a definition. Whenever you see the word kilo, you always know the value is 1,000. H stands for hecto, which represents 100. D stands for deca, which represents 10. B is our base unit, the ones we learned above, gram, liter, and meter. And I'm not sure if you've noticed, but we've actually been taking off a 0. So we've been moving 1 decimal place to the left. So the base unit's value is just 1. So now we're going to have values less than 1. So the little d stands for deci, and kind of like a decimal, it's our first decimal place. C stands for centi, so we're going to move the decimal point over 1 more time to the left, so it'll be 0, 1. Now think about it. A cent, a penny, is 1/100th of $1. So this is like the cents place or the hundredths place. And the last one we're going to focus on, even though there are a lot more prefixes than this, is milli. And that represents 0.001 or 1/1000th of a base unit. So let's learn how to use them. Kilo means 1,000, hecto means 100, deca means 10, the base unit is 1, deci is 0.1, centi is 0.01, and milli is 0.001. So whenever you have problems like we're going to have below, your first step is to underline the prefix. Then you're going to have to do a little bit of math and multiply the value of the prefix, which can be found up here, by that front number. So let's do the first half together. My first task is to underline the prefix. And in my first example, it says 1 kilogram is equal to blank many grams. So I see that my prefix, which are the words referenced for you at the top of the screen, it matches kilo. So then I see that my front number is a 1. So I'm going to take the front number and multiply it by the value of kilo, which is 1,000. So 1 times 1,000 equals 1,000 grams. So 1 kilogram is equal to 1,000 grams. In my next example, I see that my prefix is centi. It's the word that I'm not familiar with, but I see that meter is my base unit. And my front number is the number 1. So I'm going to take my front number, which is 1, and multiply it by the value of centi, which is 0.01. So 1 centimeter is 0.01 of a meter, or 1/100th of a meter. And number 3, I see that milli is my prefix, and the number 1 is my front number. So I'm going to take my front number and multiply it by the value of milli, which after looking at my chart above, right over here, that's 0.001. So 1 milliliter is 0.001, or 1/1000th of a liter. Now we're going to get into front numbers that are not equal to 1, but it's the same process. The first step I'm going to do is underline my prefix, which in this case is hecto, because it's a word I can reference at the top of my screen. Then I see that my front number is 2. So I'm going to take my front number and multiply it by the value of hecto, which according to my reference chart above is 100. So 2 times 100 is 200. So 2 hectometers is 200 meters. The last one we're going to do together, and I want you to try 6 through 10 on your own, is number 5. So I'm still going to follow the same process. I'm going to underline my prefix, which in this case is milli, and then I'm going to find my front number, which in this case is 30. Then I'm going to take my front number, which is 30, and multiply it by the value of my prefix. So 0.001, because a milli is 1/1000th of something. So if I take out my calculator and punch in 30 times 0.001, I get an answer of 0.03. So 30 milligrams is 0.03 of a gram. If you missed something in the video, go back and rewatch, but you are expected to have 6 through 10 done by the time I see you next in class, and we will use numbers 6 through 10 when you return. Thank you for watching and have a great